Good morning. How are you all doing today? Are you ready for lunch? Yeah, I can see that. So, it's good. You guys are doing a great job, and it's good that you're getting this opportunity. So I hope you're enjoying it. Make the most of it. My name is Anima. I have had a dream since I was 7 years old that I want to become an astronaut. But I grew up in India, and I did not get a lot of opportunities growing up, like you guys are getting right now, to pursue my dream. So I kept on studying and doing whatever I could at that time. But when I came to the US, that is when I started making things happen so that my dream, I could make it come true, okay? Even though it's late, I'm an old lady now, not that old, but it's never too late. And that is the reason why I continue to work towards my dream while I have a career, I pursue my career, and I share my experiences with students like you, and that's what I'm going to do today. I'm going to talk to you about my journey, but I'm going to focus more on what NASA is. I know you all are aware of what NASA is. You live in the Bay Area. We have a NASA Ames Research Center here, right? I'm going to talk to you about some of my favorite NASA missions and how we've used technology in these missions and where we've reached today. And then I'm going to talk to you about something called simulated missions, okay? What are they and why do we need to do those, okay? And I am one of the candidates. I got to be a mission commander for a simulated mission called the Hera 7. Hera is Human Exploration and Research Analog at the Johnson Space Center last year. It was a 14-day simulated mission to an asteroid called Geographos. So what was that about? I'm going to show you some pictures and tell you all those stories, okay? So let's dive into it. First and foremost, I want to talk to you about this amazing organization that I work for, NASA. What does NASA stand for? Space Administration, good job. National Aeronautics and Space Administration. NASA is the leading space research organization in the world, right? We have sent rovers and spacecrafts to every single planet in our solar system. We are the only organization that have been able to do that, right? And that is why NASA is special. You get to see, you've seen all these spacecrafts, rovers, I'm sure. Have you? What is that one up there? The Space Shuttle, right? The Space Shuttle is a great example of one of the most amazing human engineering feats. It was a spacecraft that launched like a rocket, and it came back and landed like an airplane, right? Have we seen any other spacecraft do that? No, it is sad that we had to retire the space shuttles. But the main objective of building the space shuttles was what? To put the International Space Station together. Do you guys know what the International Space Station is? I'm sure you all do, right? It's a football stadium-sized huge lab, or a spacecraft you can call it. It's a football stadium-sized spacecraft that's orbiting our Earth at the speed of 250 kilometers per hour. It completes one orbit around the Earth in 90 minutes. It's that fast. And why did we build it? Because we wanted to understand what happens in microgravity. If we wanted to perform a lot of scientific experiments to understand what goes on in microgravity. If you want to send people further into deep space, how is it going to affect their bodies? And that is why we have the International Space Station up there. At a point of time, there are 6 astronauts on board the International Space Station. Minimum, it has been 3 at very rare times, but it's normally 6 astronauts. And it can go maximum up to 9 to 12. It can hold that many astronauts. So we wanted to build this in space. Did we build it on Earth and send it into space? No, because it would cost us a lot of fuel and energy to launch anything. We have to overcome that gravity, right? And it's not easy to build something here and launch it into space. But building things in space is also really tough. And we did it. We built the International Space Station. But how did we launch all the modules of the International Space Station? That's what the Space Shuttle was designed for. So if you look at the top, that's the cockpit where the astronauts sit. The rest of that big section of the fuselage of the rocket, of the Space Shuttle, is used to put modules in and then launch them. And now that we are done building the International Space Station, we cannot use the space shuttles for deep space missions, can we? They were never designed to fly into deep space. We could send it up to the moon, but maintaining the space shuttles was becoming a big challenge for NASA, financial challenge. It cost, every space shuttle launch cost a lot of money. And that is why, and then there were two tragedies that happened, right? Challenger and Columbia, where we lost a lot of astronauts. And that is why NASA decided to retire the space shuttle. But we all still love them because it's one of the best examples of a human engineering feat, right? And that is why I include those there. You all know this guy. Celebrated its birthday yesterday. What is it? Curiosity, right? Mars. This was a big challenge too. It's a 1-ton rover. We had never landed a 1-ton rover on the surface of another planet. There are a lot of challenges when you land a rover this huge on another planet where the gravity is minimal. Okay? Why do we need gravity? There's no atmosphere. When a spacecraft is entering the Earth's atmosphere, it is slowed down by the drag that the atmosphere causes on that spacecraft, right? But on Mars, we don't have that kind of an atmosphere to slow the spacecraft down. So how are you going to slow down something as huge as a rocket that's carrying Curiosity, which is a 1-ton rover, which is just falling like a big rock? How will you slow down? So those kind of challenges, the aeronautical engineers had to overcome. And I'm going to show you a really cool video about that. It's called the 7 Minutes of Terror. There were 7 minutes of terror that the engineers and the scientists had to plan for. From the point Curiosity enters the Martian atmosphere, which is just 1% of Earth's atmosphere, to the point it lands on the surface of Mars. It takes 7 minutes. And how there were 7 minutes of terror for them, how they overcame all the problems that they might face without experimenting. And they landed Curiosity successfully on the surface of Mars. That's what the video is about. Now, why did we have to send Curiosity? We have landed a lot of rovers on Mars. Do you guys know about those? Pathfinder, Opportunity, Spirit, right? So these rovers were very small in size. They were far easier to land on Mars compared to Curiosity. And they gave us a lot of pictures, a lot of data about the Martian atmosphere, the surface of Mars. But now we wanted to understand if there is water on Mars, if there are traces of even microbial life form on the surface of Mars. We found there are traces of water, right? Curiosity it has a chemical lab on board. It can just scoop up the sand, it can put it in its chem lab, and then it runs analysis on it. And then we can find out what are the components, the chemical composition of that sand, or when it drills rocks, we can find out the composition of that rock powder, what kind of minerals are there. And in that process, we have found the Martian soil has 2% water in it. It's not enough, right, for humans to survive. 2% water, we'll have to do a lot of chemical processing on it to retrieve that water. But at least it gives us an idea that Mars had water once upon a time. After that, from pictures that other rovers sent us, Opportunity sent us, we found out more evidence that water once flew on the surface of Mars. So we want to understand what happened to that water. Where did it all disappear? Mars even had an atmosphere. Do you guys know that? It had a magnetosphere. So where did all of that disappear? We want to understand, will that happen to our Earth, even though it might take millions of years? So to understand all of those kind of things, and if we want to send humans to Mars, is it safe for them? Will they be able to survive in that kind of an environment? So we have been sending these rovers, and now Curiosity is the biggest rover that we have sent, who's helping us understand all these factors. Then that's Voyager 1. Do you guys know about Voyager 1? It launched when we all were like 3 or 4 years in 1977. And it was launched to study the moons of Jupiter and Saturn, right? Jupiter and Saturn have a lot of moons, but we did not know how they looked and what kind of moons they were. Would they have a possibility of having life on them? And that is why we sent Voyager. Voyager sent us a lot of data. Voyager 1 and Voyager 2, both of them were launched around that same time. And we got a lot of important data from those spacecrafts. But then their baseline mission was over long back. They had enough fuel. They studied all the moon. They did whatever they were supposed to do. That was their baseline mission. Now what do we do with them? We can't just discard them. They still have a lot of fuel on board, right? And they're good spacecrafts in great condition. So NASA always does this. Once the baseline mission for a spacecraft is over, and because the spacecrafts are in great condition, we assign a new mission to the spacecrafts. And that's what we did with Voyager 1. Now, Voyager 1 is the first man-made object, a spacecraft, a machine, that has entered the interstellar space. Isn't that amazing? Nothing has gone. We don't know anything about the interstellar space. What is the interstellar space? So our solar system, where does it end? What is the last planet? Pluto. Poor Pluto was a planet, but it's not a planet anymore. But yeah, Pluto is the last. It's not the last object, actually. Do you guys know there is an Oort cloud from where comets enter into our solar system? There is a Kuiper belt of asteroids in that area too. So those are the objects at the end of our solar system. And they are all enclosed in something called a heliosphere. You know what a heliosphere is? It's a plasma bubble that is created because of the plasma rays that the sun sends out. So we have a nice protective bubble. We can't see it, but we know that it exists there. The plasma rays, they extend up to a certain limit in our solar system, and they encompass our solar system into that cool little bubble that protects us from harmful radiation. The radiation out in the interstellar space is more harmful, and that's what our heliosphere protects us from. So we don't know what is out there in the interstellar space, what kind of radiation, what kind of cosmic rays. We want to understand those better, and that's what Voyager 1 is doing, and Voyager 2 is going to enter into the interstellar space soon. Voyager 1 is going in one direction, Voyager 2 is going in the other direction. And it is so far out now, it has entered that space, it has crossed the heliosphere, but it's so far out, a signal to come from Voyager, and for us to send a signal to Voyager is taking 30 days. It was 30 days a year ago. It must have, so it's going to keep on increasing, right? Because it's going further and further away from us, billions of miles. One day we will lose contact with it, and it will just keep traveling in space. But it has a gold-plated disk on board, and that disk has information about where we are. It has a map of Earth in our galaxy, so that if any friendly aliens, let's hope those are friendly aliens, if they ever find us, they will know where to find us. That gold-plated disk also has sounds from the planet Earth. It has images of things from planet Earth. So we are just sending out a friendly message out there. So let's hope that only some friendly aliens find that spacecraft, right? So that's another great human engineering feat, right? So I really love this spacecraft. And then that one up there is the Global Hawk. It's an unmanned aerial vehicle. I just put it up there as an example of aeronautical research that NASA is doing. So unmanned aerial vehicles is just like your remote control airplanes or cars, right? It's being controlled by remote pilots who are sitting in a nice little room, and they're sending these in extreme environments where humans can't go and survive. If you want to study the tornadoes that happen on the East Coast, hurricanes, right? They become category 5, and we want to understand what is going on. Why are they becoming such superstorms, and what are the wind velocities? We want to study those hurricanes. We want to study volcanoes. So in these kind of environments where humans can't go, we are sending these kind of unmanned aerial vehicles, and that's the Global Hawk. These are examples of space research that NASA has been doing. That's an example of aeronautical research. Another aeronautical research that NASA is involved in is how can we silent or turn down the volumes of the engines that are on big airplanes, the jumbo jets. If you've traveled in the jumbo jets, you feel that noise all the time, right? Especially when you're traveling for 24 hours, long duration flights. That noise is really bothersome. So we are looking into how can we silent the engines down. Okay? So those are examples of aeronautical research and space research NASA is doing. If you go to a website called spinoff.nasa.gov, you will find out how from every NASA research, there is a technology that comes out that we can use in our day-to-day lives. Can you give me an example? The golf ball, yeah. The golf ball has dimple. That's aerodynamical research. Good job. Yeah? Velcro, yeah, Velcro. Where is Velcro used? See, this has Velcro too. Astronauts use it a lot on the International Space Station or during their spacewalks. Why? Because they can just, if they need to carry something out and they don't want to hold it, they can just attach it to their flight suit or spacesuit, right? And that is why Velcro. GPS also comes from NASA and a defense research. And then microwave technology. So there is a lot of technology that arises from NASA research. And like I said, spinoff.nasa.gov is a great way to find out what all research NASA has done that we are using in our day-to-day lives today. This is just a fun slide for you guys. NASA in the movies, if you have noticed it. Why is NASA in the movies and no other space research organization in the movies? Because like I said, we are one of the leading research organizations, and we've been able to do things that no one else has been able to do so far. So you should be really proud of our NASA. This is a little bit about me. I won't spend a lot of time talking about me, but like I said, I had this dream since I was a 7-year-old girl. We had a book exhibition, and I saw cool books about the US space program, the Russian space program. I saw one picture that stuck to me was an astronaut lying in his seat on his back and launching into space. And that's when I decided I want to become an astronaut. But like I said, I'd never had the proper direction on what to do. So I just pursued my studies. I did a bachelor's in physics because I loved physics. And my plan was I will become a fighter pilot, and I'll join the Indian Air Force. And then maybe I can become an astronaut. But at that time, India wasn't accepting female fighter pilots. They just started accepting recently. But I still decided to apply. So I did my bachelor's in physics, but I couldn't pursue that because I had a slight short vision problem, myopia. Okay, it was a very minor problem, so I had to give up on that. And at that time, I felt really disappointed. All my life is over. I can't do anything now. But then I decided to pursue something else. A master's in computer applications is what I did, because that was a newer program at that time. And I finished my education. I worked in Mumbai for a couple of years, and then I got an opportunity to come to the US. And when I came to the US, I started working at a software company as a software consultant. And that's when I found out there is a NASA Ames Research Center. I was seeing the space shuttles launch regularly. And that's when I decided to do something about my dream. Anish, my son, who is amongst you right now, he was 3 years old when I decided, he's embarrassed. When I decided that I want to do something in this field, so I need to get a degree in this field, right, if I want to work for NASA. So I decided to pursue a master's in aerospace engineering. When I had a full-time job, Anish was 3 years old. I was working for Oracle, and I got to study at the San Jose State University, because that's the one I could afford at that time. I was paying out of my pocket. So I took a little longer to finish my master's because I did not have the aerospace engineering background. I had to take some extra courses, and, but I finished it. I got a great GPA. I did good in my studies. And then I was not a US citizen, so I kept applying to NASA to come work for NASA. But 2 years passed, 3 years passed, and I wouldn't even get a call from NASA because I wasn't a citizen. But in 2012, in the spring of 2012, I got lucky. The hiring manager for the Kepler mission. Do you guys know about the Kepler mission? Yeah? Cool. I will talk a little bit about Kepler in a few minutes. The manager asked me if I was a citizen, and I said yes, and he called me for an interview. They really liked my aerospace engineering and my software engineering background. Plus, I am an amateur astronomer. I love astronomy. And so they hired me right then and there for the job. I was a senior principal software engineer on the Kepler mission for about 3.5 years. Just this year, in the beginning of this year, I started working on another project now. I'm in the Intelligence Systems Division. So I'm a software engineer. I'm an aerospace engineer. But I can't stop there. I still want to become an astronaut. And I can't. I have to keep applying to the NASA astronaut program. But while I'm doing that, I'm preparing myself. Because today, astronauts cannot just be engineers or doctors. They have to do everything. They have to do, if they are, because we are going to send astronauts where now? Into deep space, to Mars, right? So if they break their bone and they're just engineers, can they take care of themselves? Is there going to be a doctor flying to them? No, so they should be able to fix themselves. They should be doctors, they should be engineers, each of them. They should be plumbers if the toilet breaks. what will they do? They can't call a plumber from Earth, can they? So they will have to be plumbers too. So astronauts today have to build up a lot of skill sets. They need to know almost everything. And that is what I've been trying to do. I've been training to be a private pilot as and when I can save a little money, because pilot lessons are really expensive. I just got scuba certified this year, earlier this year in the spring. And getting scuba certified was the toughest thing for me to do, because I never swam when I was growing up. Swimming was not that common in India at that time. So I took swimming lessons here as an adult, and I had never ventured beyond 5 feet in water. Okay, so taking scuba lessons was really tough for me, because breathing underwater was a very scary experience. All of us have our fears, right? For me, that was my fear, being able to breathe underwater. But I trained myself. I put myself on purpose in that situation, and I kept working on it, and I overcame my fear. So that's what I would like to tell you guys. If you are scared of something, don't give up. Keep pursuing it. Keep overcoming your fears. And you will definitely, and that feeling when you overcome your fears is really satisfying. Okay? And same thing, never give up. That's one of the biggest things. Even when you grow old, never give up if you want to do something really badly and you really like it. Okay? So I skydive also. It's a fun adventure for me. Whenever it's my birthday, I tell my husband, I'm not interested in jewelry, fancy jewelry. Just give me that money and I'll go and skydive. So I do those kind of crazy things. But it's just to train myself that I can handle fear and do these kind of adventures. I love scouting, so I have been den leader for both my boys, and now my older son is Boy Scout, so I'm an assistant scoutmaster and a STEM counselor for him also, and I'm really involved in those activities. It's an adventure too. And I like to stay connected to my culture. I celebrate Indian festivals with the equal enthusiasm like I celebrate American festivals. So I think we are fortunate. We are able to bring in both cultures together and take the best from both of them, right? And that's what I try to do because it helps me stay grounded. That's me on our Kepler website. There was a news coverage about my talks in India where I was interacting with students just like I'm interacting with you guys right now, so that I could give them the guidance, give you all the guidance that I couldn't get when I was growing up. Moving on. Staying fit is one important thing an astronaut needs to do, right? In general, in life, we all need to stay healthy. During the selection process for the Hera mission, we had to undergo the similar selection process just like the astronauts have to. And they check if you have alcohol in your blood. If you have been smoking, then you cannot be an astronaut because you need to be really physically fit so that there are minimal chances of you falling sick in space. And that's what I'm a non-smoker, non-drinker. I like water. Water is the best drink, right? I even don't go for fruit juices or anything. So I like to run marathons. I just became scuba certified, like I told you. I choreograph dances, and I teach dances also. We celebrate India's Independence Day also here. We have it coming up on the 20th, and I'm teaching students like you and moms like me dances, combination of Bollywood dances, basically representing the culture. I like to bike also. So I do a combination of exercises, and I think you all, I'm sure, are aware of what is important to stay fit, right? So you should continue to do that. Stay healthy, stay fit, and maintain a good, healthy lifestyle if you want to pursue something like this, okay? These are some pictures from the Project Possum, where I got selected to be a scientist astronaut candidate. And we went for training earlier this year in April. We did a lot of training. What is Project Possum? I've been selected as a scientist astronaut candidate for another project called Project Phenom. These are commercial projects right now, space projects, that NASA is supporting under its Flight Opportunities Program. And we will be doing a lot of study. For example, Project Possum is the polar suborbital science in the upper mesosphere. You guys know there are layers of atmosphere, there are layers in our atmosphere, right? What are the layers? Anyone? Yeah, troposphere, mesosphere, thermosphere, right? So there is stratosphere, troposphere, and mesosphere. All the clouds end where? In the first layer, right? Should there be any clouds anywhere else? No, the mesosphere is way up there. Should there be any clouds there? No, but scientists have found out that there are clouds. They have started observing these clouds in the polar regions, in the mesosphere. And they're curious, where are these clouds coming from? Are they harmful for any spacecraft entering our atmosphere? And they found the similar kind of clouds on Mars also, in the Martian atmosphere. So we want to understand what are these clouds, how did they form? There is no record in history of these clouds. Late 1800s is when people have made a note of these clouds. So where did they come from? The biggest theory is global warming and pollution. But it's a theory. We want proof, right? Every time, even when we are working on the Kepler mission, can we just say, oh, there is a planet in the habitable zone, it is like Earth, and there is life on it? Can we say that? No, we have to prove it scientifically, and that's what we want to do. But going up into the upper mesosphere, we'll have to travel up there, and people will have to collect data. Who will do that? There is microgravity in there. We can't just send anyone. So we need to send trained people, okay? And that's what we are doing. We are training as scientists, astronauts, to be able to do these kind of things. And we've been trained in microgravity in those kind of acrobatic aircrafts. That's the Extra 300. And there's a super decathlon that I was trained in also. We experienced, that's the super decathlon. We experienced 0G, how to handle ourselves when we are flying in no gravity. We experienced 2Gs, 3Gs, and 4Gs. You know how they feel? As if an elephant is sitting on your chest. And some people might pass out if they're experiencing heavy Gs. How much Gs are we experiencing here on the surface of Earth? 1G, right? So when the amount of gravity increases on your body, what happens is people might pass out. Everyone's body reacts differently. Someone might throw up. And we need to, astronauts need to be able to handle these kind of gravities. And we are trained in anti-G maneuvers. And that's what we did when we were flying in these airplanes. And turned out I could handle them quite well. So I was satisfied with myself. I got to know I'm strong and my body can handle the high Gs very well. We also got to train in that spacesuit. It's a Final Frontier design spacesuit. It's a commercial company that is making space suits. It is working with NASA. Now, commercial companies are going to start to fly in space. By the time you guys grow up, it will become quite common, I'm sure. So you might be some of our future astronauts flying into space on commercial spacecrafts, SpaceX Dragon or Virgin Galactic's Spaceship One. Have you seen Spaceship One? It's a cool aircraft. It is attached to an airplane. It flies up to 40,000, and then it's dropped, and then it launches like a spaceship. So that Final Frontier design spacesuit, we suited it in it. It was pressurized. When it was pressurized, I felt like a big balloon. I was inside a big balloon. And then we boarded a simulator of XCOR's Lynx spacecraft. XCOR is another company that has built its own spacecraft called the Lynx. And we flew on that spacecraft. And we reached the upper mesosphere. It was a simulation. We captured data. There is a camera called the Possum cam, which we are trained on how to use. We use those. I used that to collect data about those clouds. We had to collect sample of the clouds. Also, we'll be doing this in reality in 2019 when XCOR's Lynx is ready to fly. We will get to fly on that. So that's the kind of training. We also train in a hyperbaric chamber. You know what a hyperbaric chamber is? It's a big submarine-like chamber. And they simulate that you've reached up to 40,000 feet. Okay? So the oxygen levels are simulated accordingly. And then they suddenly decompress the chamber as if the air is going out of that chamber. You're losing oxygen. What will happen to you? You might die if you don't know how to handle that situation, right? So astronauts and pilots need to know, even when you fly in the big jumbo jets, if there is a decompression, if there is an explosion, it's gone right away. You know that it has happened. But if there is a slow decompression where there is a tiny hole in your aircraft and the air is releasing slowly and the oxygen levels are dropping, it is really difficult for a human being to realize the symptoms of that condition. And that's what we were trained in. You feel dizziness when the oxygen levels drop. You start feeling dizzy, numbness in your hands, and we had to recognize those symptoms and correct it and fix it so that we could fly our airplanes and land safely. Next I will talk about is the Hera mission that I got to do, but first I would like to ask you guys, where have we been so far as humans into space? We have been to the moon, and we've been in the lower Earth orbit. We've built the space station, right? This is just a picture. When I said football stadium sized, this picture tells you how big the International Space Station is. And that picture is a really cool picture. We always see sunrise, we see the moon rise. Have we seen an Earth rise? No, the Apollo astronauts were really lucky. They got to see an Earth rise, and they captured this picture for all of us to see, right? It's a really cool view of what we have been able to do as humans. Go all the way to the moon and look at the Earth, our beautiful blue marble rising up there. So we've been to this. Now where do we go next? NASA is planning on deep space missions. So we have been to the ISS and the moon. Now we want to go where? Mars, right? That's our next destination, because that's like a sister planet to Earth. We know it is the most similar. Can we go to Jupiter and build a habitat there? Why? No, it's gas. We need a rocky surface. I forgot to mention about Kepler. I was working on the Kepler mission. Kepler is a school bus-sized spacecraft. What is it doing? What was it doing? It's now in the K2 phase. But when it was working as Kepler, when it was launched to study about 120,000 stars in our galaxy in one section in the Cygnus and Lyra constellation to see if there are Earth-like planets in the habitable zone of Sun-like stars in our galaxy. So why are we looking only for Earth-like planets? Because Earth is our model, right, which we know. This is the kind of planet on which people like us have formed, life has formed. So we know Jupiter-like planet cannot have life. Why? It's gas, it's all gas. We need a rocky surface, right, for us, people like us to form, life to form. Can life form on Mercury or Venus-like planets? Too hot, right? Can it form on Uranus and Neptune? Too cold. Even Pluto is rocky, but can it form there? No. So we are looking for Earth-like planets, and in that process, we have found, sorry, every star has at least one planet around it in our galaxy. Can you believe that? Did we know that before? No, every star has at least one planet in our galaxy. And there are a lot of Earth-like planets out there around most of the stars. And some of them are in the habitable zone of Sun-like stars. So we are getting very close to find an Earth 2.0. Okay? By the time you guys grow up, I'm sure we will have found one planet. Then we will have to narrow down and study that planet further to see if there is life on it. Okay? So that will be our next destination, and that is why I've included this slide, because Kepler is such a favorite mission of mine. I cannot resist but include. We found Kepler 22b. It's a water planet. It was in that size range where it couldn't be condensed enough to become a rocky planet, where it couldn't be large enough so that its density is very less to be a gaseous planet like Jupiter. So it ended up something in between, like a water planet, and scientists think that it's a water planet. That one is Kepler 20b, which was our very first planet that we found. It's too hot. You can see it's a burning rock, basically. But because it was our first planet, so it was special. And these two are in the habitable zone, Kepler 452b. And this one is a dimmer star. If you look at it, there are different types of stars. That is our Sun-like star. This is red dwarf. And we have found more Earth-like planets around red dwarfs. And now we are finding planets around Sun-like stars that are in the habitable zone. So that is the closest. But it is an Earth cousin. It's still not an Earth twin. Why? Because it is slightly bigger than the Earth. Our goal is to find just Earth-like planet. Okay? So we might travel to those planets when our space travel technology has improved, and you guys can work on it and design better spacecrafts that travel at what speed to be able to reach these planets. They're really far. They are like 200, 400, 1,000 light years away. But now TESS is another telescope that has launched, that will launch in 2017, next year. It is similar to Kepler. It's going to work just like Kepler, but it is going to look at all the stars that are closer to us. Kepler was looking at a very limited number of stars in just one region, and they were very far from us. TESS is going to look at stars that are closer to us to see if there are habitable planets, so that hopefully one day to a star that has a planet which is 4 or 5 light years away from us, we might be able to travel. And who knows, when you guys grow up, we might be able to do that. You will be able to figure something out. What is that? An asteroid. We want to travel towards an asteroid also in the future, or you never know when an asteroid might come hurtling towards us, right? We want to be able to grab it. Can we let it crash in Earth and let it destroy Earth? No, we want to grab it, hurl it, change its orbit so it doesn't come heading towards Earth. But for that, we need to be able to land on the surface of that asteroid. And that's why we have planned to send astronauts to an asteroid by 2030 and to Mars also. Those are our future destinations. These are our future destinations. Okay? So that's where we go next. But before we go to these places, these are just some pictures. Have you guys watched these movies? Martian is a must watch, and if you can read the book is really good too. So these are our next destinations, but the thing is, before we go there, is it safe for humans to travel there? What is here on Earth that's protecting us and keeping us alive? We have an atmosphere that filters all the radiation coming from the sun out, right? Imagine if we are exposed to radiation, what happens? Our skin will get burned and we will die. We'll get a cancer or some sort of disease and we will die. Do you guys know about astronaut Scott Kelly? Yeah. You had a question? Okay. Yeah. We put sunscreen on our bodies when we go out in the sun. Why? To protect us from the harmful UV radiation, right? And the radiation is not as much. It's not reaching us in that much amount. But when astronaut Scott Kelly was on board the International Space Station for 1 whole year, and he came back, we got an opportunity at NASA to talk to him. So you know what he said? The radiation has damaged his skin in such a way that it's become very sensitive. When he touches it, it feels like it's burning. So it will take his skin some time to adapt. You know how long he has been in space? He has been the longest in space. He's the first human who has been that long in space. He's been there for 1 year, 1 whole year. And that is a part of this study too that NASA is doing. Before we can send astronauts to Mars or an asteroid and leave them there to die, can we do that? Can we send them today? No, we need to do a lot of research, understand how radiation, microgravity, harmful space rays, how they affect the human body. And they are going to travel in small tin spacecrafts. How long does it take to get to Mars? 8 months to Mars with the current technology we have. 8 months from Mars. And when we send them that far, can we just bring them back in a month? No, we want them to stay there for at least a couple of years and do some research and then come back, right? So we are looking at a minimum of 4 years for a mission to Mars. Now for 4 years, they are going to be away from their families. Is that going to be a good impact on their mental condition? We want to understand that. Because we are social beings. We need to be around the people we love. And how will being away from family for 4 years or longer impact their psychology? That's what we want to understand. And they're going to be in a closed environment all the time, right? On Mars, what is the Martian atmosphere made up of? 95% carbon dioxide, which is a poisonous gas for us. So can they just step out on Mars just like we step out here on Earth outside a building? No, they will die. They will have to be in space suits. And being in space suits in that closed environment is really, can cause claustrophobia to some people. Living in a closed environment, in a tin can, when you're traveling to Mars, a spacecraft is basically a tin can have reverse psychological effects. Will they fight with each other? Will they kill each other? So we want to understand all this. And that's what we are trying to do here through these simulated missions, plus with a combination of having a real astronaut stay on the International Space Station for long durations. We cannot send a lot of people in space. It's expensive. So we send one astronaut. Another one is going to be in space for another year now. And then we do simulated missions with people who are interested, who are astronaut-like material. We send them on those simulations. We keep them in isolated environments for long durations of time, and we see, they're basically guinea pigs. We were basically guinea pigs when we were in that Hera habitat. And we are being observed, we are being studied, we are being given tasks, just like astronauts would perform on deep space missions. And we are being studied, and scientists get the data and they understand how this is going to affect, and then they plan accordingly for deep space missions. That's me at the Hera habitat after I was selected, and we were training for our mission. That's in Utah, where I'll be heading next year in spring, hopefully, as a scientist astronaut candidate. We'll be living in the habitat. When we step out of the habitat, we'll be in spacesuits. I'm doing a spacesuit research, so I'll be taking that spacesuit with me, and we'll be performing a lot of tests there. That's in the Arctic region. We have a habitat there where people go in, astronauts go in, and they live for long durations of time. It's an extreme environment, basically, right? And then there's the NEMO mission. NEMO is an underwater mission. Right now, there are about 16 astronauts, engineers that are astronauts and engineers that are living underwater at the NEMO, which is in Florida. And they are doing similar kind of research. They are going to be underwater for 16 days. There is a mission where people are going to be underwater for 100 days in the future, because we might travel to planets that are all water planets. So being in extreme environments, how do people perform? How do they get affected psychologically? These are the kind of things we want to understand, and that's why we are doing these kind of missions. So that's our Hera mission to geographers. I was selected with another 3 astronaut-like candidates, and I'll show you a picture of us. And our mission was to travel to geographers, which is in the asteroid belt between Mars and Jupiter, and gather data about geographers, take samples of data, take pictures of geographers, explore the surface. We got to design our own pad just like a real astronaut mission. And that's us taking pictures before our mission began. I had to go there for a day for medical exams and psychological exams. We had to give a whole bunch of psychological exams that took 3 to 4 hours. And that's all 4 of us. There were 3 levels. The first level, we had the medical science station. That's the station behind me. That's our only way to communicate with the world, which was with the mission control. We did not have any wireless, internet, nothing. We were completely isolated. Our only way to contact with the outside world was the mission control. That was our comm station. That's the 4 of us. I was the commander. Samuel Wald was our flight engineer. Samson Fan was our mission specialist 1, and Deborah was our mission specialist 2. That was the only way for us to get up to level 2 from level 1, that ladder. We had to, I must have climbed that up and down like about 100 times during the day. So that's just a fun picture. So upstairs, we had our kitchen on the level 2. And the level 3 was our crew quarters, which was a very small space. We got to eat and try astronaut food, which is dehydrated food. We have to inject hot or cold water depending on the type of food you're eating. If it's cereal, you will put in cold water, right? So we had turns. We took turns preparing the meal. We had to hydrate them and keep them aside for 10 to 15 minutes. And because astronauts cannot feel any taste, do you guys know that? There is no gravity up there, right? So what happens to the blood? It rushes all the way to your brain. Gravity is what is holding the blood and circulating it. It's allowing proper circulation in our body right now. But in space, where there's no gravity, the blood will rush to your brain, right? And you will feel like you're having a cold. You're congested all the time. And so you won't feel any taste. Everything gets numb. And that is why astronauts have to do exercise, because if they allow that to happen to their body, they're not going to survive. So they have to exercise for 4 to 5 hours every day. So the blood keeps pumping, their heart keeps working, and keeps circulating the blood. But because they don't have taste, they really like spicy food. And that's the shrimp cocktail, which is really popular with them. And we liked it too. We got to try the shrimp cocktail. So these are the kind of things we had to exercise just like they do, but not for 4 to 5 hours, just an hour, 1 hour. We have to do cardio and we have to do the weights and all that. That's the dosimeter, which is the acoustic dosimeter, which measures the amount of white noise astronauts are exposed to. Here we were told we are exposed to only 10% of the white noise that astronauts are exposed to on the International Space Station. You guys know what white noise is, right? When a machine is working, okay, you hear zzz, that kind of noise. And up there, the International Space Station is a huge lab which is being hurled around the Earth. It has its own mechanism going on. Is there atmosphere up there? No. So there is an atmosphere that has been generated. So astronauts are breathing. What is coming out when they are breathing? Carbon dioxide. Can they let the levels go up? No, they'll die. So what do we need? A carbon dioxide removal system, right? That is a big system. It keeps working too. We can't grow plants. We've just started growing plants there. We can't take plants up there, right? But there is a machinery. It's a system. It's called the carbon dioxide removal system. So there are a lot of electrical power system, thermal control system. You can't let it get hot and cold. You have to maintain a temperature for the astronauts to be healthy, in healthy condition. So it's basically creating a living environment up there. And that all has a lot of machinery humming and working, and it's creating a lot of white noise. But on deep space missions, that white noise will affect you in some way. And that's what we want to understand. And so we have that acoustic dosimeter. I did not like it a lot because it was very heavy, and that yellow thing wasn't very good looking. So I was modeling there a little sarcastically, modeling the acoustic dosimeter. We had to wear it for 24 hours. It did not measure what we were talking. It was just measuring the amount of white noise we were exposed to. That's the crew quarters. That's the airlock from where we had to do our medical and psychological conferences. We got to talk to our families also. And we did a lot of different studies that astronauts do. That's a special microscope with which we studied asteroid samples. Then we simulated the commander fell down. How are you going to handle that emergency? Radiation levels went up. How are you going to handle that emergency? Our flight simulator, there I'm measuring the temperature with an infrared thermometer. We built rovers because astronauts will be doing that in the future. What was I going to talk about? Okay, so we were kept awake for 40 hours, no sleep, 2 days, no food, 2 days. Blood was drawn from us at the beginning and at the end of those 2 days to understand. We were simulating that we've entered a storm of asteroids, okay? And can we sleep when our spacecraft is going through asteroids, traveling through asteroids? No, we will get hit, right? So we had to keep flying our spacecraft, and we have to, astronauts won't be able to sleep on in a real mission scenario where that kind of an event happens. And how will we handle that? Can they stay awake for that long? How will that affect their health and their psychology? That's what we were studying. And that's when the mission was over. That's my website. I have a Facebook page and a website if you guys want to send me any questions. There are some videos, but let me see. I had a video to show you guys which tells you about the 7 minutes of terror that I was talking to earlier. Where is it? Okay, there. So let's see, how long is that? It's 5 minutes. It's a really good video. It tells you engineers of all kinds, be they software engineers, aerospace engineers, they run into problems, right? How do you overcome those problems? So let's watch it.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divergent maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels, on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Was that a cool video? Yeah. So did you see the number of problems they faced, right? They knew that there wasn't enough atmosphere to slow the spacecraft down. So what did they use? The supersonic parachute. That parachute was tested here at NASA Ames Research Center in that big wind tunnel that you see off of Freeway 101.
Ready. Copy that. All right. And we can confirm through EHA now that the VCBs are in manual charge mode.
I can't hear you. No, that's not the wind tunnel. That's the hangar. It's the oldest hangar built in the late 1800s. It was used to house the airships at that time. They were big. So it has been unskinned now. He's asking about that big hangar, just the skeleton that you see at NASA Ames. It is an old hangar which was from the late 1800s. The skin was made of asbestos. And asbestos, as we know, is not very healthy. It's not environment healthy. So they've unskinned it, and now because NASA didn't have enough funds to reskin it, so we have leased it out to Google's Planetary Ventures, and they are going to do something with it now. But the wind tunnel is the other big structure that you see out there, and that's where the supersonic parachute was tested. And I will answer your couple questions in a couple of minutes. Let me finish, otherwise I'll forget what I was talking about. What was the other problem? They had to use the sky crane. Did you see that? Why? Because the spacecraft that had those little engines, rocket engines fire up, it would kick off dust, and it would put the dust on the spacecraft, on the rover. What would happen if that happened? The rover has what on board that is needed to power it? Solar panels, right? If the dust falls on the solar panels, will it be able to generate power? No, so we couldn't allow that to happen, and that is why we use the sky crane. So these are the different kind of things scientists and engineers came up with before landing Curiosity. And it's amazing they didn't get to test it, experiment it in a similar environment, but we still successfully landed it. It was landed on August 5 in 2012. So August 5th was Curiosity's birthday. Okay, so I hope you had a great time. If you have any questions, can we take them now? Or I could talk to you. I'm here till the end of your day, so you can come and talk to me.
We have time for just 2 questions. Does anybody have any questions they want to ask right now, or do you want to hold on to them for lunch? Should we ask and hang out during lunchtime and chat?
Sure, yeah.
All right. Any last questions? All right. Thank you so much. That was amazing. And just to close, I think you've definitely inspired all the students here today, and you've had such an amazing journey yourself. What would your words of wisdom be for the students and your words of advice as they move off into their futures?
I would say that, see, I have chosen a difficult dream, and you might too, right? Not everyone gets to fulfill their dream of becoming an astronaut. A lot of people have this dream. Yes, you can keep working towards it. The thing that is against me right now is my age, right? Age is the factor that's against me. But does that mean I'm going to get disappointed? No, because I already know I've gotten a late start towards working towards my dream. But if I don't fulfill it, I still have a backup plan. So that's what I would like to tell you guys. Dream big. Pursue your dreams, but always have a backup plan so you never get frustrated. I plan to continue working at NASA, to continue doing research in space, working space exploration, working on projects like the Phenom and Possum. So never give up and have a backup plan always.
Great. Thank you so much. That was amazing. Great big round of applause. Thank you.
Thank you. Hope you all had fun.